Lesson 109 is about advanced trinomial factoring. And so far we've only factored trinomials that have a coefficient of 1 on the x squared term. So having a coefficient greater than 1 can be challenging, but if it's prime, it's actually not very difficult. So let's just take a look at the first example I have there. First thing we want to notice is that it's not in descending order of the variable. So we want to start off by putting it in that descending order of the variable. So we start with the x squared term, 2x squared minus 7x minus 15. So now we know that 2 is prime, so it can't be, it's only divisible by 1 or by 2. So we know that that first term has got to be a 2x and the other one has to be an x. We have a subtraction here at the end, which means that one of these is going to be positive and one will be a negative. But at this point we really aren't sure which is which. We do know that that when we add our outside and inside, if you were to FOIL it back, you would want to end up with a -7 here. So in our multiplication, we want to make sure that the larger number is negative. And then we just have to start thinking through the factors of 15. You have 1, 3, 5, and 15. So just looking at it, we want to be able to subtract and get 7. But 15 and 1, if you multiply, basically if you subtract 2 from 15, you're not going to get 7. So you know that those won't work. So it has to be 3 and 5. So then you have to figure out where does the 5 go, where does the 3 go? Well, if we put the 5 here and the 3 there, then we end up with -6 and +5, which would give us a +2. And that's not right. So what if we swap the 5 and the 3? Put the 5 here and the 3 there. And these pluses and minuses are very fluid. Like we could choose a minus there and a plus there. That's what we have to figure out. Which one do we need? Well, if we put a negative here, when we multiply, we'll get -10, and we'll get +3 here. So -10x plus 3x is going to equal -7x, just what we wanted. So we know that this is our answer. That is the correct factorization of that polynomial. Okay. Here's another one. This one's already in correct order. So we can go ahead and make our parentheses, and we can know for sure one's going to be 3x, one's going to be x. And this is super simple because 2 is also prime. The subtraction sign shows us that one of these is going to be positive and one's going to be negative. We don't know which is which yet. We have to think through that. But we do know that we want the larger one to end up negative. So if we put a 2 here, that's going to give us 6. 6 minus 1 is not doable. So what happens if we put the 2 there and the 1 here? We have a 3 and a 2. So 3 minus 2 is 1. We want the 3 to end up negative, so it's got to go with the 1. Because that's what the 3 is being multiplied with. And then the positive will go here. So that is how you factor when your leading coefficient is something other than 1. And they can definitely get more difficult than that. If you had something that was not prime as your leading coefficient, but all the examples I have here, the leading coefficient is prime. So if we wanted to find the intercepts for this quadrilateral, then what we would have to do is set each of these equal to 0 in order to find it. So 3x plus 2 equals 0, and then we would solve for x. So here x would equal negative 2/3, and there x would equal 1. Okay, so all that means is that when you graph it, your parabola is going to go something like this. Okay, this is way too far over. Obviously, 1's not that far away from the origin, but you get the idea. This would be negative 2/3, and this would be 1. Okay, so that's what those numbers mean. Do the rest of the problems on your own, and okay, so for lesson 110, it's about vertical shifts, horizontal shifts, reflections about the x-axis, and combinations of shifts and reflections. And I thought I would show you some of this on Desmos because it's a good way to really kind of see what happens when you change up your equations. So, and this way you can kind of see what I'm doing. All right, so if you wanted to, you could explore this a little bit. Look, you can do histograms, box plots, dot plots, all kinds of interesting stuff. And logarithms, you can do square roots, and pretty much anything that you could do on a scientific calculator. Now, I would love for you guys just, with some of the free time you have over this break, you could actually experiment and explore, and they have different basically lessons you can learn from this. So let's say we want to graph that very first problem, f of x equals x squared plus 3. See how that turned it into a parabola, x squared plus 3. So remember, without that plus 3, it's just going through the origin. But you add on the plus 3, and that shifts it up on the y-axis. Because when x is 0, y will be 3. Okay. Now, what happens if we put x plus 3 in parentheses and then square it? So parentheses x plus 3. So see how it's a straight line? It's because we haven't squared it yet. You square it and it becomes a parabola. So you'll notice what that does is it gives you a shift in the negative direction. And the reason that is that x would have to be a negative 3 in order for y to be 0. So that's your second one on there. Of course, yours says g of x, but it doesn't really matter that I didn't change that f to a g. So what would happen if you put a negative sign out front? Well, hopefully you remember, because we actually already kind of did a lesson over this. If you put a negative sign out in front of this one, it'll just flip it upside down. So for this lesson, for these practice problems, I really would like for you to sketch a graph of the functions. It doesn't have to be perfect, but you can choose x's and y's, and you can also explore on desmos.com to better understand those problems. And we will definitely talk about it in our Lesson 111 is more on conjunctions and disjunctions. We've done these a little bit, but this is an interesting setup where you have x in between two different inequalities. So in order to do these, the first thing we have to do is to solve for x. So of course we're going to need to add 4 to both sides, but both sides becomes every side. All right, you have to do it to both sides of the inequalities. And since you have 2, you have quite a bit of adding of 4 to go on. So we end up with x less than 6 greater than or equal to -1. So then we have to draw this. Now, this is where you have to be kind of careful, because I've told you before that if x is to the left of the inequality symbol, then the inequality symbol tells you which direction. Obviously here it's to the right of this one, so you can't use that to figure it out. You have to use your noggin a little bit more. So you 0, 1, 2, 3, 4, 5, 6. -1, -2, -3, -4. All right. So we know that we're going to have an open circle at 6. I'm going to change colors here. Open circle. And we're going less than. So x is less than 6. But the other limit is that it's integers. Okay? If it's integers, then we're not going to have the in-between numbers. So there's not going to be a dot at 6, but there will be one at 5, 4, 3, 2, etc., all the way down to -1, because it tells us that x is greater than or equal to -1. So and we actually don't need, we do need the line, but we don't need that hole at 6. Let's go ahead and just do these 3 that are right here. The one right below that first one we did is x is greater than 15, or x is less than or equal to 10. Our domain is real numbers. Okay, so we will be using arrows this time around. So let's just start with 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So x is greater than 15, so that does not include 15, does it? And it's real numbers, so we can draw our arrow. And x is less than or equal to 10. This is a disjunction, right? And lastly, let's do this third example down here. Okay, check out our domain. It's integers. And we're, let's say, -5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so -x is greater than -3. So we have to change that one and multiply both sides by -1. So we get x is less than 3, because when we multiply by a negative, we have to flip our inequality. Or x is greater than or equal to 7. That one we don't have to do anything to. So less than 3, we can put our circle at 3. Oh, yeah, less than or equal to 3. and go less than. And x is greater than or equal to 7. There we go. Okay, here's lesson 112, more on the multiplication of radical expressions. So we've done some multiplying of roots, and now what we're going to be doing is foiling with those. So let's look at our very first example. When we FOIL it, we're going to do first, outside, inside, last. All right, so first is 2 times 3, which is 6. And then outside is 2 times the square root of 8, so plus 2 root 8, plus inside 3 root 2, plus the square root of 16, because the square root of 2 times the square root of 8 is the square root of 16. So now we can simplify. What do you see in the square root of 8? What perfect square is within that? Well, it's 4. 4 times 2 is 8. So we can pull that out. So we end up with 6 plus, when we take out the 4, it comes out as a 2. So we end up with 4 times the square root of 2 plus 3 times the square root of 2. And the square root of 16 is 4, so plus 4. Well, we can combine our 6 and our 4, and we end up with 10 plus 7 times the square root of 2. And that is our final answer for that one. Let's come down here to this last problem on the left, the square root of 2 plus the square root of 5, quantity squared. Okay, when you have these, take my advice and multiply them out. Excuse me. You have to write them out, square root of 2 plus 5, square root of 5 times the square root of 2 plus the square root of 5. Okay, and once again we're gonna FOIL. So we get the square root of 4 plus outside the square root of 10 plus inside the square root of 10 plus the square root of 25. Okay, well, the square root of 4 is 2. I change to black because the blue doesn't show up so well. 2 plus 2 times the square root of 10, right? Plus 5. The square root of 25 is 5. So our final answer is 7 plus 2 times the square root of 10. The only thing I'm going to warn you about here on when you do these practice problems on your own is to watch out for these subtraction symbols and make sure that you're foiling properly and taking those